Hello, I'm Brianna,
I'm Mariana.
and today we are presenting on
Fischer esterification.
Firstly, we will give you an introduction on Fischer esterification, which is a special type of esterification by refluxing a carboxylic acid and an alcohol in the presence of an acid catalyst like sulfuric acid. The alcohol used in this reaction is generally a primary or secondary alcohol. Tertiary alcohol is not used as they are prone to elimination, which is caused by the strong acid catalyst. Fischer esterification is an example of nucleophilic acyl substitution based on the electrophilicity of the carbonyl carbon and the nucleophilicity of the alcohol. Nucleophilic means that the alcohol donates a pair of electrons to the carbonyl carbon of the carboxylic acid, while electrophilic is the opposite of nucleophilic. Direct acylation of alcohol with carboxylic acid is preferred over acylation with anhydrides or acid chlorides. The main disadvantage of direct acylation is the unfavorable chemical equilibrium. The mechanism for nucleophilic acyl substitution varies depending if it occurs under basic or acidic conditions. Under basic condition, a strong nucleophile can attack the carbonyl carbon, thus generating a tetrahedral intermediate. A tetrahedral intermediate is the change in carbon from sp2 hybridization, trigonal planar geometry, to a sp3 hybridization, geometry. This intermediate can then expel its leaving group like water. An example of nucleophilic acyl substitution is the hydrolysis of ester. Under acidic conditions, the carbonyl group becomes protonated, thus activating towards nucleophilic acyl substitution. The carbonyl group is then attacked by a weak nucleophile, which generates the tetrahedral intermediate. The leaving group is then expelled, which is often a neutral molecule. Moving on, we will go through the steps in Fischer esterification. Number 1. Protonation. Addition of H+ or protons of carbonyl occurs as carboxylic acid takes a proton from catalyst concentrated sulfuric acid. This occurs to make it more electrophilic. The one in green is the one taken from the catalyst. Second, the alcohol's oxygen functions as the nucleophile attacking the electrophilic carbon in the carbonyl with the electrons moving towards the oxonium ion. Oxonium ion is any oxygen cation with 3 covalent bonds. A hydrate of ester is then formed. This is the hydrate of ester. Third step is deprotonation of alcohol occurs as a proton is transferred from oxygen of the alcohol in a process called tautomerism. Tautomerism is isomerism in which the isomers change into one another with great ease so that they ordinarily exist together in equilibrium. Fourth, this causes more of this OH group to leave to give water. Fifth, deprotonation occurs to cause hydrogen to be removed from oxygen by reaction with the hydrogen sulfate ion which was formed during step 1. 6. This forms an ester and a water, and the sulfuric acid catalyst regenerates.
How do we increase the yield of Fischer esterification? So as the reaction is at equilibrium, the Chatter's principle is used to shift the equilibrium to the right to produce more esters. Firstly, we can decrease the concentration of water or increase the concentration of alcohol. Secondly, we can use a Dienstag trap which collects water and reduces the amount of water in the mixture, thus increases the yield of the reaction. So this is a Dienstag trap. Now, I will explain the advantages of Fischer esterification. Number 1, the reaction involves simple reagents, products, and conditions which are non-toxic. Number 2, it causes less environmental impact in terms of waste products and is less harmful. Number 3, it only needs small amount of acid catalyst to accelerate the attainment of equilibrium. Number 4, it is thermodynamically controlled. The reaction tends to shift towards the more stable compound during the reaction. Moving on to the disadvantages of Fischer esterification. Number 1, the reaction is thermodynamically reversible. The change from initial to final state occurs by extremely small changes. Number 2, it is a relatively longer reaction time due to the reversible reaction. Number 3, water is produced, which causes the mixture of compounds to be more diluted and decrease the final product yield. Fischer esterification is involved in the production of medicine, such as benzocaine. Benzocaine is synthesized by Fischer esterification with p-aminobenzoic acid, PABA, ethanol, and sulfuric acid as the catalyst. Benzocaine is a local anesthetic used in medical applications to reduce pain and increase comfort of painful drugs. It is also used to numb the skin or surfaces of mouth or rectum. The mechanism of benzocaine starts off by the attack of one of the hydrogens of the sulfuric acid by the carbonyl of PABA. The oxygen then becomes protonated, causing the cleavage of the double bond. The oxygen of the ethanol then attacks the carbon of the carbonyl group. The lone pairs of the sulfur then deprotonate the ethanol's oxygen, leading to the formation of an ester group. One of the hydroxyl groups binds to an hydrogen of the sulfuric acid, leading to its removal from the central molecule. The negative charge of the carbon results in the formation of a double bond to the OH group. Due to the newly found positive charge of the hydroxyl group, the lone pairs of the sulfur group deprotonate it. Thus, the nucleophilic substitution of this reaction results in the change between the hydroxyl group of the carboxylic acid to an OCH2CH3 group. This results in the formation of the benzocaine and water.
Thank you.